Hi, this is Ayush Kumar, and I'll be talking about Keystrokes Dynamics in the field of authentication. While going through this PPT, I'll be talking about what biometrics is, how are we doing the feature selection and the attribute selection, what are we taking, like biometrics has different techniques. We'll be talking about those techniques. What are the advantages of Keystroke Dynamics? What are the disadvantages of Keystroke Dynamics? What do we get out of this project, and what can we do in future using Keystroke Dynamics? So when we talk about user authentication, like you can see, it is divided into three vast bases. One being knowledge base. When we talk about knowledge base, the computer or the person already has the knowledge about what the person and who the person is. Object based is more like you need an object for authentication, like ATM cards when you need to get the cash out, or RFID cards, which is used in all companies nowadays. And then comes biometric based. Biometric based is again of two types: psychological, physiological, and behavioral. Physiological are the physical features like fingerprints, face recognition, retina, iris retina, hand geometry, and other such things. Keystroke Dynamics is part of behavioral. There's other things which is part of behavioral are like lip movements, how you use mouse, gait analysis, which is how you walk, voice recognition, signature recognition, and of course keystroke recognition. Why exactly biometric authentication? Like in this particular project, what people did is, without using any external hardware, we could authenticate the person and authenticate him pretty nicely. I already talked about physiological and behavioral biometrics. Now, physiological biometrics, physiological characteristics are used in many places. Like you may have seen those sci-fi Fast and Furious movies or MI5. So you have seen how these particular features are being copied and can be changed, can be copied, can be took away from some places. That's how the world is modifying and advancing. Behavioral characteristics are more difficult to copy, as a person can't copy exactly how a person walks or the pattern in which he types. Similarly, so this table represents how and where the different biometrics and are used. So you can see keystrokes are almost used everywhere with high efficiency and low error rate, whereas other biometrics have been researched upon, but keystroke is a new field and is getting researched on. So behavioral measurement, aiming to identify user based on typing patterns, rhythms, is what keystroke is all about. So there can be different modes to check those. One is identification mode, that is one-to-many, and one is verification mode, that's one-to-one. So there are different keystroke techniques. There's where we can apply different keystroke techniques. One is fixed text and one is free text. I'll talk about free text first, which is widely researched upon because the efficiency of free text is pretty low right now. So many may have done Coursera courses when you register for a course or courses, they ask for your face, that is facial recognition, and then they asked you to type a paragraph. There is where Keystroke Dynamics comes in. So the paragraph is random, so you don't ends free. So every time you enter back, you need to enter the paragraph. So the efficiency of those algorithms which are applied for free text are pretty low, as your friend also can type those paragraphs and get accepted. So the size may vary, the number of characters may vary, the number of words may vary. So they generally look at the pattern at which you type, maybe how you type the letter, the word Y, WHY, or maybe other such patterns, like you may take, when you press the full stop, you take more time than other people. So those things are taken care when you talk about free text. Now comes fixed text, which is talked about in this paper and has a higher efficiency and more algorithms to work on, and has pretty high accuracy compared to free text. Generally, fixed text are used in online applications for password verification, as the password is fixed. So this is how the overall design of biometric section looks like. First, you need to acquire the data and store it. Once you acquire data, there are many redundancies. You need to do data cleaning. You need to extract high quality features from the data. Once you have got that data, you need to formulate, build a model, represent that data, and put it in a database, and using that model and the incoming data, you output the decision that the person is authenticated or not authenticated. So what are the things we take into account when we are doing or building keystroke models? So we can take into account typing speed, keystroke seek time, the flight time, the characteristics of the sequence vectors. That means what's the difference between particular difference between A and B when you're talking typing A and B, and where do we make maximum errors? Like, people may have habit of typing a colon instead of typing L. So these things are taken into account. I already talked about this, and there are other features which are taken into account, like frequency of error, the pressure, which needs different keyboards. But generally, when talking about keystroke, we want to keep the keyboard same, and we try to take the latency and dwell time and key down time, key press up time, such things. So how will you know that the model is good? So we have different error rates so that we could know and we could calculate the accuracy and the error in the model. So using these error models, these rates, we can say how good a model is. So first one is false rejection rate. So this is the one where the person is the right person but still he is rejected. False acceptance rate is where the person is not the real person but he is authenticated. Equal error rate or crossover rate is where different values of operating may result in different values of FRR. So we need to keep FRR and FAR as minimum as possible in any scenario of keystroke. Now we can classify, or we can authenticate the user using different methods, statistical methods, neural networks, pattern recognition, hybrid techniques, and other such approaches. We'll be mainly talking about statistical methods. So when we talk about statistics, the first thing which comes in everyone's mind is mean. So yeah, there is a mean model and there is standard deviation model. There are digraphs, geometric distance, Euclidean distance, Manhattan mean, KNN, which is a machine learning model, a Markov model, Manhattan distance model. Now, these particular statistical methods can be improved on, maybe have changed a little bit during your application, which can enhance the accuracy of authentication. These are the wares where we can use keystroke. Now, keystroke has many advantages over normal methods. So it's software only, you don't need external hardware. It's very simple to deploy. It's easy to integrate when a open source keystroke model is built. It's non-invasive, cost-effective. Don't need to train it again. The algorithms handle it. It's very simple, can be used over internet. You don't need special software to be installed in your system. So it's pretty easy, cost effective. Like whatever you need, it's there in keystroke. Yeah, of course there are drawbacks, considering like your one finger is damaged, you can't type the same pattern. Your pattern may change when you grow older. Sometimes you may be tired and your pattern changes. There's some hi-fi keyboard in the market which you want to buy, and then the model changes. So it's under research and it will be game over in few years. But right now, these are still there and are there. So these are challenges based on models. So how to benchmark those models, how to know how we can improve the efficiency. We need to require adaptive models. We need low error rates and such things. So what I can conclude through this presentation is keystroke is very efficient and can be used easily and be integrated easily into any web application. We have different statistical methods which still need to be researched, but right now if we can use keystroke in many different web applications. Thank you very much for listening to me in this presentation. Sayonara.